In order to do science, we must take measurements. These measurements are the data with which we can corroborate our theories. For this reason, we have to understand what a measurement truly is and what it entails. Any measurement will contain three things. First, it must be quantitative. It must convey some kind of magnitude. This means that it must contain a number. If we ask how long some distance is, we can't say purple or happy. The answer must be a quantity. This number can be large or small and contain many digits or few digits. Second, the measurement must contain a unit. To report this distance, a number is not enough, because if we say 12.7, then 12.7 what? Feet? Miles? Millimeters? The unit gives us some kind of reference for context, which is what gives the measurement meaning. And lastly, because measurements are always approximations, since we can never measure anything with infinite precision, any measurement will have to indicate some uncertainty, which is reported by the last digit that is reported, implying more precision than this is not available. One way that we will commonly report measurements in science is by using scientific notation. This is especially convenient for reporting quantities that are extremely large or small, and it works like this. A number in scientific notation will always start with some number in between 1 and 10. It can have as many decimal places as are necessary, but it can't be less than 1, and it can't be equal to 10 or greater. Then we multiply this number by 10, which is raised to a particular power. This represents the magnitude of the number. For example, we would write 100 as 1 times 10 to the 2, since 10 squared is 100. For 1,000, it's 10 to the third. For each power of 10, we increase the exponent by 1. That means that instead of having to write 23 million, we can just write 2.3 times 10 to the 7. This is what makes scientific notation useful. We can describe a quantity that would normally require dozens of digits with just a couple. The exponent can also be negative, and that will give us tiny fractions of 1. Each time the exponent becomes more negative, we add another 0 between the decimal place and the first digit. To convert between the two forms, we just move the decimal place the number of times indicated by the exponent. 6.4 times 10 to the 8 means we move it 8 to the right, and this is what we get. 7.1 times 10 to the negative 4 means we move it 4 to the left, and this is what we get. As we said before, measurements all need units in any type of notation, so we must know the SI units, especially those for length, mass, time, and temperature, which are meters, kilograms, seconds, and Kelvin, respectively. Once we know these, we can express values of any magnitude, large or small, using certain prefixes. For example, kilo means 1,000, so a kilometer is 1,000 meters. Nano means a billionth, so a nanogram is a billionth of a gram, or 10 to the negative 9 grams. These prefixes apply to any unit, so they are easy to remember. And that's what we need to know about scientific notation.